Okie dokie. Let's dip back for a moment, right? So we're still looking at sort of what's happening with our trig functions across all four of these quadrants. And when we were sort of drawing our triangles originally, we said that once we're out of that first quadrant, the triangle really is not necessarily connected to the actual angle itself. The angle, right, when it gets to be bigger than 90 degrees is too big to fit into a right triangle. So in theory, you're using sort of a what we call a reference angle. And so let's officially go through and sort of lay out how you would actually find the measurement of a reference angle relative to the measurement of the angle itself. So we'll go quadrant by quadrant, right? So our original angle is theta, and our reference angle will be theta prime. So theta is the angle. Theta prime is our reference angle. So let's draw some stuff. So if we just do sort of a generic quadrant 1 angle, what happens for us here, right, is the reference angle is exactly the same. So in quadrant 1, right, theta and theta prime, the angle and the reference angle itself, are equal to each other. No issues whatsoever, right? I mean, the quadrant 1 angles don't really sort of need a different angle as a reference angle because they're already less than 90 degrees. They're already less than pi over 2. So we're off to a pretty good start, right? No real work to do there. Obviously, things will get a little bit more involved once we shift out of the first quadrant. So what about quadrant 2? Okay, so let's think of the perspective here. So in quadrant 2, what's going on? So theta, right, is this outside angle. The reference angle, where we're actually sort of drawing our triangle, triangle comes down here. Oh, I did my coloring backwards. Oh no, that's not so helpful. Let me see if I can fix this. Nice work. Sure, that looks great. So theta prime, right, is the reference angle, is that sort of inner angle, the one that's less than 90. So what's the connection between these two? So they should add up to 180, right, because they're going to sum together to get you this sort of straight across. So the angle itself is somewhere between 90 and 180, and then this is going to make up the difference. So to get our reference angle, so in quadrant 2, what you're going to need to do is take 180 degrees and just subtract off whatever the original rotation is, right? So however much your sort of original rotation is subtracted off, you'll be left with only the reference angle. This is, of course, also true if you're in radians, right? This would be in radians, pi minus theta. Right? Straight out is 180 degrees or pi, right? 0 degrees or 0 radians, 360 degrees or 2 pi. 90 and 270, of course, here, but we're actually not going to use those for our reference angles. What about quadrant 3? So trying to draw this generic that's 45 degrees-ish. But again, we're not really being super particular about what our measurements are. We're trying to do these as just generic setups. So in quadrant 3, let's do this rotation like so. So our original angle is here. So what's the rotation to get our reference angle? So what happens now is the triangle actually sort of goes backwards up to the horizontal axis. So the reference angle is only going to be that rotation from 180 down to the terminal side. So it's that difference again between 180 and the angle, but now the angle itself is actually the bigger value. So your reference angle is always supposed to be a positive that's somewhere between 90 degrees and 0. It's the reference angle is always sort of referring back to the first quadrant. So for us, what's this going to look like? So this is actually theta is bigger. So theta minus 180 degrees, or if you did it a radians version, theta minus pi. Something like that. So visually, right, we're getting similar pictures each time, but there's just like one little change in each of these quadrants. So we definitely have to be mindful about which quadrant we're in when we're sort of doing some calculations to find these. If we wrap up quadrant 4, again, just sort of as a generic value. Let's sneak this rotation in here. So the angle itself, right, is in green, and then our reference angle is now going to make up the difference between that terminal side and 360. So this is sort of similar to the setup in quadrant 2. So this is going to be, what, 360 minus the original rotation. We need that difference. So 360 degrees minus theta, or if we're in radians, 2 pi minus theta. So finding a reference angle is just a matter of figuring out first which quadrant you're in, and then as sort of a step 2, once you know the quadrant, which of these sort of calculations to do. Let's just sort of run a couple quick examples. I'll try to keep this picture in front of us. So find the reference angle, theta prime. So how about theta is 150 degrees? Okay, first things first, we just need to figure out which quadrant we're in. 150, right, is going to be quad 2. Kind of visually somewhere out like this. So our reference angle is going to be that extra rotation to get from 150 down to 180. So theta prime is going to be 180 minus the 150. Right? So that difference, I probably should have tried to draw that a little bigger. So our theta prime here, the reference angle is 30 degrees. So it's the amount of rotation we need to get from 150 down to our 180. What about, how about theta is 275 degrees? Which quadrant are we in? 275. 270 is like straight down, right? Would be here. So 275 is like just 5 degrees past, like due north. So we're in quadrant 4. I tried to draw a little sketch, right? We're just sort of just barely past. So our theta is here. So our reference is not the 5 degrees, right? It's sort of tempting when you're close to the vertical to sort of do a reference to that instead, but you're always trying to do a reference back to the horizontal axis, back to the x-axis. So for us, our theta prime in quadrant 4 would be 360 minus our 275. Those are pretty far apart. I mean, almost about as big of a reference angle as we could get. The difference there is going to be 85 degrees. And that'll be our theta prime. Let's do a radian version. Part of what is happening here, really more than anything else, we kind of need to be able to find our sort of quadrant pretty quickly. So when we're working with radians, so let's say we have something like 5 pi over 4. We need to figure out relatively fast which quadrant we're in. And so the quadrants, right, kind of break down in half, right? 0 is here. Pi over 2, right, is like 1/2. 1 pi is here, is like 1. 3 pi over 2 is here. That's like 1 1/2, and then back around to 2 pi. So 5 pi over 4, if we think of this almost like converting from an improper fraction into a mixed number, this would sort of be 1 1/4 pi. So 1 pi is here, so then 1/4 pi past that. So we should be in quadrant 3. So our theta is here, we're in quadrant 3. That position sort of determines what kind of math we should set up. You can kind of see it up here in that third quadrant. Our reference is the difference between 180 and the angle. In radians, of course, that's going to be pi and the angle. So the angle is bigger. So this is going to be 5 pi over 4, which is our theta, minus 1 pi, which is our sort of 180. What math do we need to do to actually sort of do this? So now that we're in radians, we need to do a little bit of fraction work. We'll do pi. Think of this like pi over 1, right? And times 4 over 4. We need to get common denominators here before we can do any kind of subtraction. You could probably do a lot of this work again if you're just thinking of this in terms of the fractions. If you're thinking of this as like, well, 1 1/4 pi minus 1 pi, you can pretty quickly sort of reason that you're going to be left with 1 pi over 4, right? 1/4 pi. So 5 minus 4 pi, right, is 1 pi all over 4. And that's going to be our reference. 2 more quick examples. If we had an angle that was like bigger than 1 rotation, so let's say theta was, I don't know, 580 degrees, and we have the same question, find a reference angle. So what we really need first, what we need is a coterminal. So before we determine the positioning, right, I mean, we can kind of figure this out on our own if we want to, but really our reference angles are sort of built on angles between 0 and 360. So if we're working with 580, that's just kind of too big by itself. We need to do a subtract a rotation off of here first. So let's do 580 degrees minus 360. What are we going to be left with? 220? 220 degrees. Where's that going to put us? That's going to put us in quadrant 3. So then as far as our reference angle goes, so these have the same positioning, right? Which means that if we rotated 580, we'd go all the way around and then back to quadrant 3. So for our reference angle, we're just going to use 220. We'll subtract our 180 off of it, and we're going to be left with, 40 degrees. So our reference angle there would be 40 degrees. You can imagine sort of a similar type of thing if we maybe had a negative angle, right? So maybe this is like negative 7 pi over 6 or something, right? So find the coterminal for a negative. So let's do negative 7 pi over 6. We're just going to add a rotation. We'll just add 2 pi. That would look kind of like 2 pi over 1. This is sort of relative to 6. So we'll scale this up. This is sort of negative 7 pi over 6 plus, what, 12 pi over 6? So we're sort of working with 5 pi over 6. 5 pi over 6 would be, right, bigger than 1/2, less than 1. That's going to be in quadrant 2. So that means for our reference angle, theta prime, we'll do pi minus 5 pi over 6. And just to save a little space, right, pi would be 1 pi would be 6 over 6 pi minus 5. The reference angle here is going to be a single pi over 6. As a general rule for our reference angles in radians, if we're working with either, right, a pi over 6, a pi over 4, or a pi over 3, those are sort of our big 3 radian angles, 60, 30, and 45. The reference angles for those will sort of always refer back to the smallest angle based on the denominator. So something over 6 is going to sort of refer back to a 1 pi over 6, over 4 to over 4, and over 3 to over 3. Check it out, but that's typically what's going to happen.